Okay, this question wants us to do three different things. I'm going to show you how I'd approach it in terms of getting those three things done in the right order. So the first one wants to explain the difference in boiling point between sodium chloride, so that's going to be my first one, and then water is going to be another one I'm going to do. And then the next bit says, explain how this difference is used to choose the method to separate them. So my third step is describing how these are separated. Okay, so let's go through the information and I'll show you the points that need to be covered for this. So first of all, I'm going to deal with water. Water is a covalent substance, and that means there are weak forces between the molecules. This is the picture I would draw. So there's my water molecule, and there's another water molecule with the covalent bonds in. And then here are the weak forces between the molecules. And what I would then say is that the boiling point is low because not a lot of energy is required to break the weak force. So to break this force and pull these two apart, we don't need a lot of energy supplied. Compare that with sodium chloride. So over here is sodium chloride. Sodium chloride is ionic, and because it's ionic, it has strong electrostatic attraction between the ions. Again, here's my little picture showing my ionic lattice with the positive, negative ions and the force of attraction, the bond between them. I would then say that the boiling point in some is high, and that's because a lot of energy is required to break the bonds, to rip those ions apart. So I've done my two structures. Now I'm going to explain how to separate them. So I'll come down to this bit, and this is how we separate them. So we would separate them in a process called distillation, and this here is the equipment we would use to do distillation. I'll draw a nice little picture. I'd label it. This is my condenser. This is the round bottom flask. And what you would do is you heat the mixture of water and sodium chloride, and the water will boil first because it has a lower boiling point. The gas will rise up into the condenser and it will come through the condenser. Now the condenser is cold because there is cold water flowing around the outside of it, and that causes the gas to condense and turn back into pure water. So I get pure water formed here because my salt is left behind in the round bottom flask over here. So that's how I would do it to explain it. All the points covered in the question.